everybody, welcome to the Real-Time Ray Tracing in Unreal Studio webinar. My name is Darryl Aubert, and joining us today we have George Matos from NVIDIA, as well as Tim Johnson and Jason Wong from Buildmedia. So with that taken care of, I'll give you a quick overview of Epic Games, Unreal Studio, and the new hybrid ray tracer before handing over the presentation to Buildmedia and NVIDIA. Epic Games operates as two major divisions, publishing and software. Through its publishing division, Epic Games is the creator of the world's most popular game, Fortnite, and has a history of other big hits. The software division of Epic Games serves game developers. There have been over 500 titles created by third-party studios, and there are thousands of enterprise, non-gaming customers using the engine every single day. In 2016, we set up an enterprise team to address the specific needs of enterprise customers, and I'm part of that enterprise team. We've grown to 70 people from 20 in just the last year, with a dedicated engineering and support team of 30 people in Montreal. You'll find the enterprise team in the UK, Germany, US, Korea, China, and Japan. We're literally all over the globe. Unreal Engine is a complete package with all the features you need to make unique, compelling, film-quality real-time experiences, and it's free to use. With Unreal Engine, you can use the same assets to create different deliverables, everything from still images to mixed reality, or in the film world, everything from virtual production on set to final frames. And you're not limited to which platforms you can deliver content on. Unreal Engine runs on all major desktop, mobile, and game platforms. The engine's been extremely successful. We've had over 7 million downloads of Unreal Engine and 200,000 registrations to the Unreal Studio beta. Visualization experts in architecture have figured out for themselves the value of Unreal Engine in Unreal Studio. A recent survey by CG Architect found that Unreal Engine was the #1 real-time solution for production rendering, and the #1 renderer respondents were experimenting with, including traditional offline renderers. We want to make it easy for existing professionals as well as those just entering the job market to skill up on real-time. Last year, we launched our online learning platform with over 30 free online courses that enable you to learn from experts anywhere at any time. We also offer instructor-led training classes with centers in Guildford, Los Angeles, Munich, and Montreal and Detroit coming soon. Unreal Academy is our main learning event, which we hold 2 times a year with both hands-on courses and lecture-based talks. With the new hybrid ray tracing, Unreal Engine offers the quality and ease of use you strive for without the time cost of full ray tracing. Using an NVIDIA Quadro RTX graphics card, reflections, soft aerial shadows, translucency, ambient occlusion, skylights, image-based lighting, and global illumination can now be ray traced, while other passes continue to be rasterized. By opting to ray trace certain passes, you get to balance and tune the visual fidelity versus the performance and frame rate perfectly to your asset's needs. Next up is Tim and Jason from Buildmedia. They're going to show an interactive application to visualize and sell apartments before they're built.
Hello everyone, thanks for joining us today for this webinar on Unreal Engine's new hybrid ray tracer running on NVIDIA Quadro RTX cards. My name is Tim Johnson, I'm the Technical Director here at Buildmedia, and with me today...
Hey, I'm Jason, and I'm the Senior Real-Time Artist here.
So, Buildmedia is a company that's been around for 16 years. We specialize in architectural visualization and infrastructural visualization. We do still images, animation, and interactive. We have been using Unreal Engine for a few years now, and just recently started to incorporate ray tracing into our workflow. So before we get started, I would just like to show you a sample of our work covering architectural, infrastructural, and interactive projects using a mix of pre-rendered and real-time workflows. So firstly, before we jump into showing you some of our ray tracing examples, I thought it would be a good idea just to quickly cover why, as an architectural visualization studio, we are starting to incorporate real-time engines into our workflow. So firstly, what we are seeing is really an explosion of interactive content out there, and also a growing need for more personalized experiences in all avenues of our lives. And we feel that today people are looking for solutions, and really needs to be based on helping that user. People want information delivered faster and in a simpler format. We're also seeing a shift towards more interactive for real estate, and also property developers are employing more interactive strategies really to engage and educate their buyers. Real-time interactive is really effective as a sales tool. It's engaging. We can see that with video games out there, and other real-time applications using Unreal Engine. Not only that, it delivers relevant content quickly. It's like a two-way conversation. You ask it a question, and that answer is delivered to you very, very quickly in a format that's easy to understand. And if you can create something that's engaging and delivers relevant content, it basically inspires confidence. So we're also seeing younger buyers now coming into property who expect more interactive content to help make their decision. The way architects are designing, using game engines like Unreal Engine to design their architectural buildings. So our property developer clients are being exposed to more interactive design solutions. So they're wanting to take that across to their marketing as well. Again, social content, this whole concept of standing out and trying to get above the noise, and how to do that with more content. We're seeing Unreal Engine and NVIDIA really disrupting our industry in ArcViz with the technology that they're offering now. It's really exciting for us just to see its potential for our clients. One way we are using Unreal Engine and NVIDIA cards is to allow our clients to actually create their own renders. So we call this an instant render function in our real space tool. This is quite an important aspect of it. It allows buyers as well to create their own custom images if they're looking at material options, views out windows, lighting scenarios. They can customize it, create their own image, and it's emailed directly to them. This is really, I feel, quite disrupted in terms of the architectural visualization space, where traditionally we were creating 4 or 5 images of an apartment, a living room, kitchen, bathroom. Those were then reused over and over again for marketing over the year, whereas now our clients have the ability to create more content, keep social media fresh, allow their buyers or potential buyers to actually create their own images very, very quickly. And this is, of course, only possible with using Unreal Engine and NVIDIA cards. We have a company in New Zealand called TradeMe. This is our leading property marketing website here in New Zealand. They did a study on the number of images that were within a listing versus the number of people actually adding it to a watch list. What they found was listings with a minimum of 10 or 20 images typically saved to a watch list at least 45% the rate of listings with fewer images. 45% is massive. So for us to produce 10 or 20 images in a traditional rendering workflow can get pretty expensive quickly. So obviously, you need images of a high quality, and thanks to Unreal Engine and NVIDIA, the ability to do this now in real time and produce images so much faster is becoming a reality. And this is having a direct impact on property being sold online. So very quickly, I'd just like to introduce RealSpace, our interactive show suite tool. It is driven by a touchscreen and also supports virtual reality. And this gives buyers a full immersive experience before purchasing a property. right, so let's get into it. We'll show you our first example of ray tracing. Jason's going to quickly introduce the project, and then we'll get into some of the details of what we actually did with it.
So this is the CAD project running in the RealSpace Interactive Suite using Unreal. Here we've got the exterior model. You can look at it from any angle. It's designed to replace the traditional architectural model. From here you can pull up any information on any unit. So once in the interior, you can explore every part of the space, every single room, and it gives a purchaser just a better understanding of the space.
So this is the project using Unreal Engine's new hybrid ray tracing running on NVIDIA Quadro RTX cards. This is the model, so you can see it's fully interactive. We have the ability to switch on and off GI, so we can toggle that just here on the left. And we can see that the bounce light is really sort of brightening up some of these darker spots in the model. What we have done is used Unreal Engine's sun position calculator that accurately sets the location, date and time, and incorporated a slider here so we can really see how shadows are starting to play with that building located in Auckland there. We also have the ability to change seasons, so we can see here as we move through the day, the sky tower basically casts a shadow across that part. And ray trace shadows, this is really great. You don't have to set anything up apart from just activate ray tracing, and it all just works. And what we find as well is that the ray trace shadows seem to work a little bit faster than the cascade shadows as well. So it's a really great tool for shadow studies.
You might notice that the trees there are a bit simplified as well. That's just because the foliage tool doesn't quite work with ray tracing at the moment. Another really awesome thing about using GI is it means this massive city model, none of it needs to be light mapped.
Yeah, so we can incorporate actually a lot of geometry using the ray trace shadows there, and it works really, really well. Okay, so let's jump into the interior there. So this is a very large penthouse, and what we're doing here is we've activated translucency and reflections in Unreal. We have the ability to move around the space and explore it, as Jason explained just earlier. But with some of these materials, we can see just what a difference it makes having reflections and translucency. So with the little toggle up here on the top left, we can switch on and off reflections. So as you can see, the difference between what a reflection actor can capture versus what ray tracing captures is pretty drastic, and you do get a much better reflection on the table there. If we move across to here, we can see reflections in the glass. Without the ray traced reflections, again, you know, this is a reflection actor capturing this interior scene and reflecting that onto the glass. It's not very accurate. It's something that we've just pretty much been happy with, haven't we, Jason?
Yeah.
But you know, now having ray tracing capability using Unreal and NVIDIA Quadro RTX cards, you know, you can see it's just awesome for glass, and it has really improved it dramatically. And we can see inside here in the courtyard just how sort of drastic that is as soon as we start activating you know, the glass and having multiple, you know, tinted windows here reflecting the space within. If we really quickly just race across into the master bedroom there, where we'll see the bathroom with the mirror. We can see, you know, switching it on and off, what a massive difference that is. A mirror, well, it just works with ray tracing. It's great. Here's a reflection actor, just a spherical one. The difference is humongous. And if we do translucency as well, so we've got the glass next to the mirror, you can see just how it reflects that light just far better and more accurately there. So Jason, do you want to maybe just quickly mention what we're doing with the lighting for this scene?
Yeah, so this is a hybrid ray tracing and static lighting setup. So all the lighting is completely static, just to keep the performance up. So the exterior lighting uses an HDRI plugged into the skylight, and the downlights are created with spotlights. And all the strip lights that you've seen are just used using emissive objects. And I'll let Tim talk about this special area.
Yeah, cool. So we created a cool little cinema here. Again, with reflections on the floor, you can see them being activated and deactivated, but translucency is a big one. You know, we can see the glass table and the glass doors here. If there is no ray traced translucency, then basically it's picking up the screen as it was when the level loaded, which was white. But now activating that, we can see the screen being lit here accurately of what's actually being presented on the wall. And as you can probably see, we're doing a little bit of bounce light in there, so we can talk a little bit about how we're doing this in the next screen here. Okay, so the way we did this, this isn't I suppose a ray tracing feature, but it's something that was incorporated in 4.22, I believe, and this is the use of rectangular lights. Now these are great little lights for doing sort of faked bounce light in a cinema. You can see here on the right, cast ray trace shadows. We've activated that to soften the shadow line and create a bit more of a diffuse light. Within this rectangular light there, oops, sorry, I'll just search the right bar. What we're doing is we're actually incorporating a blurred version of what's actually being shown on screen. So you can load up images into the rectangular lights, and that's just great for, I suppose if we simulate this here, it's just great for creating these sort of bounce light features within a cinema. So what we've done is we've used 3 different rectangular lights. We've got one that's projecting light away from the screen into the room, which creates this sort of bounce light here. We've got another rectangular light being used to bounce light back out of the projector there, and a third one which hasn't got the ray tracing activated, but it's just basically reflecting light into a reflective surface because we have ray tracing reflections on. So you know, you get this really great example here of just mixing ray tracing shadows with ray tracing reflections, and yeah, it just looks really cool. Okay, so let's jump into our second example using Unreal Engine and NVIDIA Quadro RTX cards. It's not just interactive presentations that we're interested in, but it's also creating animations using real-time engines. And this is because using pre-rendered techniques, frames can take some time to render, whereas if you can get things working interactively, you're creating frames so quickly that animations can be rendered within minutes on a machine there. So this is a project that we created roughly 5 or 6 months ago for a client. It is an interactive presentation as well, but here we're using ray tracing to produce an animation with better reflections and translucency than what's available with reflection actors.
So I'll just touch on the lighting setup here before we go into that. So similar to the cab project that we just showed before, this scene also uses baked lighting, though this time the skylight and HDRI is doing most of the work as it's daytime. This workflow means people that are familiar with offline renderers should feel right at home.
Yeah, and also one other thing we want to mention there is with animations, you know, you need a little bit more bounce light through a scene. So what we tend to do with our animations is we'll bump up the reflections as well to typically around about 3, because we find that gives us a really great result where we will eliminate all black spots. Because basically if you only have one bounce, if you think about the rays shooting at that reflective surface, it's coming back, but it won't bounce back towards that reflective surface off another surface, if that makes sense. Well, you'll see. We'll show it later on there. Okay, so going back to my terrible explanation of bounced reflections, what we see here in front of us is that reflective light in the animation. So at the moment, the maximum bounces are set to 1. For the animation, we bump that up to 3. So when we do that, we can see immediately that that's actually creating a reflection bounce of the material over here. So what we're doing is we're eliminating some of those blank black spots that show up when you have two very reflective surfaces. And basically when we set up our animation, we would typically go 3 bounces minimum, and then we would up our samples per pixel to where we felt we're happy with the result there. So taking it back to 1, if we just fly over to this point here. So one other thing as well that we do is adjust the max roughness value. So the roughness value here basically determines if ray tracing will calculate the reflection, or will the reflection use more traditional methods like the reflection actors or the screen space reflections. So if we just play with this now, what we want to do is we want to find a value that we are happy with visually without pushing it too far. If we were to just use 1, then we're sacrificing some FPS or frames per second there. So we kind of want to try and find something that is sort of a happy balance between frame rate and roughness value. So if we just show FPS there on screen, so at the moment, our target usually for our interactives is around about 30. If we were to bump that up to 1, we can see that's dropped down to 25 FPS. So, something like 0.2, it's 60 FPS. So this is where, you want to try and balance the roughness and the post-process volume to find a happy medium where you're getting your frame rate that you need, but also have a visual quality that you're happy with as well. Okay, talking about roughness, one of the things that we do go through all our projects, if they need to be interactive, including ray tracing, is to adjust each material. What we're doing here, if we just show ray tracing, debug menu, and roughness, is we're trying to adjust the way that ray tracing reacts with each material, especially with roughness and normals. And we want to change the roughness values to either a 1 or a 0. It won't change the way we see it on screen. It will change the way the ray is interacting with that surface. So calculating a ray with a 1 or a 0 is far faster than calculating a ray with a roughness value of 0.5, let's say. So if we look at that roughness value of this table, we can see that it's sort of a rough value of maybe 0.5 using a material. So if we open up that material there, what we want to do is use something called the ray tracing quality switch, and this will basically replace that roughness value with something far simpler, either a 0 or a 1. Now remembering this will show up in reflections and translucency, but what we see on screen won't change. This is because Unreal is a hybrid ray tracing solution, so what we see on screen is still the rasterized complex material, but by using the ray tracing quality switch, the reflected contribution will use the simplified material graph. But doing this will help a lot when it comes to frame rate. And we will definitely do that with things like ceilings and floors, because they're such large surfaces, they really do take a hit on frames per second. So if we compare the roughness value of our ray tracing versus the roughness value of the material itself, we can see that the materials on screen still show up the way we want them to, but the way that those rays are interacting with that material is optimized as much as it can. So try to use 1 or 0 if you can. Obviously, you've got to keep in mind how that will look in a reflection or translucent surface, but this is a great way of optimizing a scene. Let's jump into our third and last example using Unreal Engine and NVIDIA Quadro RTX. what we have here is a animation and interactive. It's utilizing some of the things that we've just shown you with the cab exterior mixed in with an interior as well. We will first show you an animation just of what we're up to with this project. It is still a work in progress, but it's something we're pretty keen to show everybody in this webinar. So here's the animation. This is the interactive, so we can see immediately ray tracing is enabled there, showing objects that are off screen. So we can see here the chairs actually being reflected, which are just around the corner. You'll notice as well that we've incorporated our sun changer as well, which is the geolocated blueprint that's built into Unreal Engine. And this enables us actually to test how sun comes into a apartment interior. So with this, we're using ray tracing shadows, and we have the ability to move that sun over a specified time of day, and kind of see how that sun will actually come into the space. And we can see the quality of the shadows using ray tracing is just fantastic. We see the soft diffuse part of the shadow up here, and it starts to get harder as it gets closer to an object. So things like the table legs really show this off really well, where it's really hard shadow versus, let's go over here actually, the soft shadow it's passing of the window frame there. So it really helps to ground objects as well, and looks far superior to the traditional cascade shadow in a space. So we also have activated ray traced ambient occlusion as well in this example, as well as reflections and translucency. You can see with this table over here, activating and deactivating reflections, what a drastic difference that makes to things like table lamps that are on that surface there. You know, we get a proper reflection, which really makes the object grounded on that reflective surface, and it looks really good. We love the shadows in this space, and the way that direct light coming into the room is just casting those shadows. I'll let maybe Jason, can you explain kind of how we're lighting this scene, how that's done?
Yeah, so this is also using backlighting, so similar to what I've described before. However, we've also got a fully dynamic directional light as well on top. So the baked lighting is a little bit softer. So rather than using a strong HDRI, it's quite ambient. It doesn't have that direct sun, so there won't be true overlapping suns. And that allows us to have this fully dynamic sun here.
So yeah, I suppose the HDRI that we're using is a very soft light.
Yeah, you would want to use something like an overcast.
Yeah.
Or maybe even make one up yourself.
Yeah. Cool. So yeah, mixing these two light sources, again, you know, the hybrid solution of using ray trace shadows with a baked light source, we're getting the sort of best of both worlds, really. Yeah, and again, reflections, massive difference. Well, for us as artists, it's all a bit in the detail. And again, translucent objects reflecting things behind us. And yeah, overall, this is a really great scene just to kind of highlight how Unreal's hybrid solution using ray tracing can be used. Okay, so very quickly, we just want to touch on the ray trace soft shadows that are being cast by the direct light into this scene. If we just move the scrubber left and right, we can see that this is just connected to an animated object there, just to show that it's dynamic. Under the directional light settings, what we do to soften that shadow is we adjust the source angle of that light. Currently, we've set it to 2, but typically it is set to roughly 0.5. 0.5 is correct for a non-cloudy day, but because our background environment is using a photograph with some cloud cover and is a little overcast, we've increased this value to 2. If you go any further up to values like 5 or 10, you can really start to see the difference there of how softer the shadow becomes the further it is away from the object. So really it's a personal preference for your art style, but the source angle is what's used to adjust that. And if we look at our post-process volume there, we can see what we're using for the translucent settings for the glass. I'll scroll down. Okay, so for translucency, it really depends on the number of glass objects that are overlapping. So if we set it to 1, it works, and you can see that there is a reflection in that translucent glass, but we're missing a bit of depth. So really what we tend to do is we'll up the max refraction rays until we're happy with it. Max roughness values typically will stick around about 0.5 just to try and optimize the scene. For animations, we'll push it up to 1. Anything less, it's probably not that useful. So 0.5 or 1 is typically what we're using. We'll keep shadows activated in the translucency. If we deactivate the shadows by just clicking under there, so here if we disable shadows, you can see that the floor doesn't, in the reflected glass doesn't have any shadow, so it's quite bright. If we enable hard shadows or area shadows, that basically helps a lot with the visual quality of the glass. We keep glass very subtle. At the end of the day, we're not wanting an overpowering reflection there, typically in our scenes. So yeah, that's how we set it up. That's pretty much us for this webinar. I'd just like to thank everybody who's joined us today. I hope what we've shown you has maybe inspired you a little bit, helped you understand maybe some of the concepts around real-time ray tracing with Unreal Engine and NVIDIA Quadro RTX cards. It's a bit of a learning curve still for us. We've still got more to learn, and yeah, just keep an eye out for some of our projects there. We're a studio based in New Zealand, and we're trying to push the boundaries as far as we can take it using Unreal Engine. And we're super happy with Unreal and NVIDIA. The technology that they're providing us as architectural visualizers is fantastic. From me, thank you very much.
Yep, I just want to say thanks for tuning in, and I hope you guys found what we were showing interesting.
And yeah, so we'll be hanging around for a Q&A, so fire those questions through and we'll be happy to answer. Thanks a lot.
Thank you. I want to thank the Buildmedia team today for putting together an amazing presentation and showing us their workflows. Also, I'd like to thank the Unreal Engine Enterprise team for hosting the webinar. And lastly, thank you to those that are attending. My name is George Matos, Senior Tech Marketing Manager here at NVIDIA within our what we call our ProViz group, also known as our enterprise group, and we focus around the Quadro lineup. My main focus is around the AEC industry. I spent about 20 years in the AEC industry before leaving. Now, today, I focus on customers, hardware, and software partners. Today, I'd like to talk about our first ray tracing GPU, which is based on our Turing platform. So, two things that came with the Turing announcement, the RTX, are what we call RT cores, ray tracing cores, and tensor cores. So the ray tracing cores allow you to do real-time ray tracing, which Unreal 422 takes advantage of. And then our tensor cores take advantage of artificial intelligence, machine learning, and deep learning. With the Quadro lineup, we offer 4 variations from an RTX 4000 all the way up to an 8000. Now, a couple things within the Quadro lineup is we offer very large frame buffers, as you can see, the memory footprint, so 8 gigs all the way up to 48. Now, as you increase in those cards, your CUDA cores, ray tracing cores, and tensor cores increase as well. Also, with the Quadro lineup, we have a 3-year warranty, and we have, with our Quadro drivers, we have what we call ISV certification. So this certification is done with software vendors to basically make sure that the Quadro card and the drivers are running your application at optimal performance. Now, also within this, we came out with industry first GDDR6 memory, NVLink interconnect. So for example, if we took 2 RTX 8000s and used an NVLink adapter, it would give you a 96 gig frame buffer. So multi-GPU support if the software supports it, HK HDR ready, next gen VR. So if you notice on the back of the card there on the bracket below the display port, there's a little opening that looks like a little USB-C. That is for virtual link, which is future HMD connections. And thank you for attending.